I'm going to start off explaining this test information by showing some documents. So first of all, there is a document given called I'm on the wrong one here. It would be this one, T-BERD MTS 5800 quick traffic quick references. It was one of them that was given. That is this document. It's Viavi's layout on how to set up the test, but not necessarily specific to the carrier. So it'll just go as kind of a quick card on all the primary steps on what to do as a reference, and it is a really good reference for what's going on there. The other documents that were given are kind of substandard for test parameters. There's a couple different documents that show previous tests, and they're not exactly accurate to what they're wanting now, but it is kind of a baseline. So what I've been going by is this document here, which is also not accurate, but as accurate as we're going to get. So where the confusion comes from on this test is people misunderstanding what they were writing for notes. We're not talking about 1 gigahertz and 10 gigahertz. We're talking about 1 gigabit and 10 gigabit. And so there's some misunderstanding of what people are trying to interpret on what a RFC 2544 test is, what it does, and what the baselines need to be. But I am vaguely following this for now, and we're going to see what happens. And what I'm going to go over on this, on how to set it up, ended up being an hour and 45 minutes to run the test that I did on the parameters I had set up just as a base test. That's going to be determined by each VLAN, I believe. So on a system that we're dealing with, when we have dual radios and A2C, we're going to have two separate VLANs, and those independent VLANs are going to be throttled by capacity on each of those radios. So I'm pretty sure we're going to have to run each of these tests twice, and because they need to be in each VLAN to verify it can run its max capacity. So I am going to show on the tester. All right, to start off with on the tester, it's going to determine what you're doing for testing on which ports you're using. But for an understanding of how to set that up, these are going to be considered port 1 if they're the lighter purple, violet, if you want to call it that. And then port 2 is going to be associated with these. Now, obviously, this is, maybe back up on that. So this being a 5800-100G, that is very unlikely that normal field procedures are going to have this tester. This tester is designed for 100 gigabit throughput for network operations where it's just not necessary in a standard scenario. So where people have been concerned on Verizon, most guys are going to have a 1 gigabit tester, and that's not enough capacity now to do these dual radio scenarios in certain situations. So you would want a 10 gigabit tester, which is substantially more money than the 1 gigabit. But as far as this being 100 gigabit, that is why we have the quad SFPs, because the only way you're going to get 100 gigabit capacity on fiber is with a quad SFP. So we're dealing with, when it comes to fiber, they're going to be 2.9 to 10 gigabit on the Aviat. We're dealing with 10 gigabit fiber SFPs on the multi-mode for the primary traffic into the CSR, which is why I couldn't test with my set of Exfos when I had it racked up here, because they're 1 gigabit and it wouldn't even accept the 10 gigabit SFPs. In this scenario, I'm just doing baseline testing because of what I have. I don't have any multi-mode fiber sitting here. I could use my Juniper SFPs for multi-mode and try to test between these, but I don't have any fiber jumpers, and I don't want to overlight the CIPRI ports here by trying to use my 10 gigabit or my 10 kilometer single mode SFPs. So I have it set up in test port 2, which is going to be relevant when we start looking at how these testers perform together and how you set them up. So for now, I just have my other one sitting over here in idle. I have them connected. But what we're going to end up doing is we're going to go to the test button up top, and then up top here under Ethernet, that's where we decide first of all what we're dealing with. So in my case, it's 10100 or 10100 1000 gigabit. When you go to there, it's going to drop down for additional tests, including some layer 3 stuff. When you're dealing with layer 2 stuff, then you're dealing with, at the MAC addressing level, when you're dealing with layer 3 stuff, you're dealing with specific IP layers addressing. And so we're going to hit RFC 2544. We're just going to do a L2, layer 2 is what that means. On the OSI table, if you don't understand what those mean, that's where that comes from. And then traffic. Now this is grayed out on P1, but that's what that means, is which ports are we? Port 1 and port 2. So any of those. Well, obviously we don't have a gigabit Ethernet port capable on the P1 options, so it only gives us P2. So it is now going to launch the enhanced RFC 2544 test. I'm not sure if you're dealing with just a standard T-BERD 5800. You've got the standard and you've got the version 2 5800s. I'm not sure if they're technically enhanced. I'm guessing they're just going to be called standard, and I'm guessing that has to do with this unit being capable of doing at the speeds it's capable of passing through. Might have some additional capabilities of this testing. So we're just going to start this with start new configuration. I'm not sure if it's going to hold some base settings that I had. We'll see when we go through this, but to at least explain a few things here. Takes a little bit. So we're going to want this to be throughput with down and upstream are the same, and we're going to want it for traffics generated locally and measured locally with a loopback. So what people don't understand when it comes to Ethernet testing over BERT testing and old school just T1 and DS1 testing, where you used to be able to do a hard loopback, the reason you need a device as a loopback and the reason you need 2 units to do a Ethernet test, no matter if that's 2544 latency, what just specific testing, is because Ethernet packets have to have headers on them with destination addresses, and they have information, including VLANs. If you have a VLAN tag on there, all the information needed for where the traffic's coming from and where the traffic's going, and depending on the devices it's going through, those headers change information, and when you get to the other end, it has to then reverse that information and create the destination back to here. That is what a loopback does. That loopback device has to be there to edit the header information to return the traffic. So that is why there is no such thing as a hard loopback in any kind of Ethernet testing. You've got your frames, which is your MTU size on everything, which your MTU size has to include your header also, depending on what you're doing as far as setting that. But you have to have that to pass traffic. So we're creating this as a loopback. You can do head-to-head testing, which would be where we downstream and upstream, where we're basically generating bidirectional traffic through 2 testers. But as far as I know, we don't care about doing any type of head-to-head testing for this. We're just doing a simple loopback. So it's measuring traffic, going down and coming back. You're going to go into this screen. This is the important one on this screen, this encapsulation right here. If you don't have a VLAN tag on your traffic, then you're going to hit none. If you have VLAN, which we're going to on these radios, this is where you're going to put your VLAN ID in. And so on the 8740s on the link aggregation, they're set up with VLANs, and that's how it's passing traffic. It's might be multiplexing traffic depending on how it's set up between two radios, but it's utilizing a VLAN tag to push that traffic through. So that is where I'm going with. If you have two independent links going up to those two radios, they're going to have independent VLANs most likely set up, where they're going to have to each individually be tested independent. So we would put in this case, Lyman to Ariba has 16 and 17 are the VLANs that are configured. So I'm putting in 16. That's how I did that original test as well, because it doesn't know that I don't. It's putting a tag on there and reversing it back into here, but it doesn't have equipment throttling whether it does or doesn't have that tagging on it, since they're just back-to-back testing. Now we're going to go into here. Do you want to use a configuration template? No, by default. Okay, we are back to normal. So what I'm going to do, and I'm not 100% sure if they want packet jitter as well. I'm not seeing that in documentation. If you look at the Viavi information, they're saying add packet jitter. Jitter is typically something we are looking at when we're looking at Ethernet, and I don't know how much additional time that's going to add to the test if we do add that, but probably not that much. So I've enabled back-to-back as well, because by default it's just these three tests. So for now we're doing that. This is where you have to set. So for in this scenario, it's set by default what the max ability of that port is, and that's how I ran that test. But on a microwave system, you need to know what your capacity or microwave's capable of passing through on each of those VLANs, and it needs to be modified on your max bandwidth right here. And there's a couple of things I'm not 100% sure if we want to change, so we're going to leave them default for now, which is bandwidth unit. That would be normal on this screen, I think, regardless of what they say. Wouldn't change. Now here is your packet sizes. And because I added a VLAN, it's manipulating these baseline packet frame sizes. This is back to that original settings Word document where it says 64, where you're not going to modify that. You're going to keep that at 68, because that's a 64 bit packet, byte packet size plus the VLAN header, creating it as 68. So by default, these are all the same, with the exception of they're pretty specific about 2000. So we're going to modify this one. It'll let you modify them larger. Whoops. You just can't go smaller than those specific frames. Now I'm going off the original information, but if I look in my documentation I have on that 8740, the MTU size on those ports for traffic is set at 10,000, and the reason 10,000 is relevant in this scenario is that's when we're getting into jumbo frames. Anything over 1514, actually I think 1514 might be, I think anything over is considered a jumbo frame, but it's called a mini jumbo frame. So when you get into the 9,000s is where people are associating actual true jumbo frames. The MTU limit is set at 10,000, allowing those jumbo frames in the microwave, but this information is showing as 2,000. So for right now, I'm leaving it at 2,000, but I'm questioning whether we should actually be setting that at 10,000. We're going to do a standard test. This is one I'm just at 10 megabit per second accuracy is what default is. I'm going to leave it. Okay, this is another one, the bandwidth granularity. I'm going to leave it, but I'm not 100% sure if that needs to be changed at this time. Okay. Okay, word max burst, is that one that... I'll leave that. I think I left it last time. I'm looking for... Okay, here's what I caught before. So this is configure test duration separately. We need to hit yes, because there's differences between your throughput and your frame loss duration and your trials on that information. So according to that, our throughput duration needs to be 240 seconds, but our frame loss duration needs to be 60 seconds. And then our back-to-back repeats is 50. So we need to have individual settings by clicking that. Then we're going to go next. Now, I'm going to show pass-fail on all this. I think for a $30,000 unit, they could give us a little better stylus to work with. Okay, skip save pro. This is where if we get everything dialed in, we can just save a profile with all those settings. Now, obviously, the VLAN tags are going to change, but you can modify that on the go. But we're just going to go in and we're going to run tests. So now we're going to verify that we have a link connection, and this is where it's obviously way easier to do when I'm back-to-back than on microwave to verify if there's something going on. So we're going to start that test, and again, we're just still on the home screen over here on this one. But the fact that this is green and this is green is already good. That's telling us that we're up, we've got sync, we've got negotiation with that port. So we're going to start it. It's creating an active loop. It's holding that active loop with the remote tester. Measuring throughput to verify that the throughput we set is okay. It's analyzing that link. Showing us that we're good on that measured throughput. Now, what I would be curious about is if it fails, I'm guessing it's going to give us an actual throughput that it was capable of. So on a microwave scenario where we're dealing with licenses, and if we get something wrong, I'm hoping that it'll basically fail and say, no, it's not allowing the throughput you set, but here's what we had. We're going to go next, and we are now on that primary screen. So I can hit run test, and it's going to start that test, and at any time, so it's now started. So I can click on this, and this is showing me where we're at, and as it goes through, it'll fill these in. So right now what it's saying is it's running throughput and latency. So the thing about RFC 2544 is it's kind of a, I guess we'd call it a dinosaur of a test. It is a baseline test, but what it does is it takes independent individual tests and runs them at specific byte packet sizes and then passes and goes to the next. Some of the newer version testing, that's where when I'm running, say, the EtherSAM test on the XFOs, which EtherSAM is proprietary to XFO, but it's a generated base test that other people use now under a number scheme, just like this 2544. It is using latency, throughput, and jitter simultaneously at whatever you set, or random packet sizes throughout. So it's more replicating real life traffic and then verifying everything is good. In this case, it's going to step everything up and individually verify that each process is good and then give you a pass or fail result, which is why from a time standpoint, dependent on every single thing you change with your repeats and with your durations, you don't necessarily get a final test time until it knows everything's done, and it's every single thing you do depends or dictates how long that is. So you would have an understanding after you do some of, yeah, with these settings, it's about this. But every time you add a byte size, when you check that, every time you change your duration, every little item is going to change the length of these tests. They used to be the baseline was essentially a minimum of 24 hours on the test. And so where they're talking a quick test, short test they call it, and they're saying around an hour. I had an hour and 45 minutes, but I'm guessing that when they were replicating that hour, it was probably with less frame sizes at some point, and then they had that as a baseline. So when these are done, then this will start, then this will start, then the test will stop. At any given time, you can utilize some of these other buttons to go back and modify, but once the test starts, you don't really want to touch it. You can touch this, and you can go back and you can look at what's happening, but as far as modifying settings, you're obviously going to create problems. Now, let's slide over and see if I can get this to show. This, even though it's running, and you can see traffic is up on this port, it doesn't look like anything's happened on the remote end. So if you're on the remote end, you really want to go to here and click up here. If I can get it to go. Okay, this is a summary page of what's going on with that traffic. So I can see over here of what my throughput is currently, what my frame loss is, what my packet jitter is. This is live data reading for that test. And over here I can see that I've got a link active, frames are detected, VLAN frame is detected. So this will kind of tell you what's going on. But if somebody walked in, if you just set this up remotely and went to the other site, and you could be running an active test, but it would just look like a home screen. So you wouldn't want somebody to walk in and unplug that and create test problems. And it's always good if you're on the remote side to be watching this on the payload. That should be all I've got to go over for now.